Hi everyone. So welcome back to our channel, becoming a ROS developer. Today we've got Omar who has just completed his project, ROS 2 Basics with Python. Sorry, it's ROS 1. So he's going to give a presentation about how he went about his project, and then we'll see a live demo of his code running on the real robot. And then after that, we'll do a review of his project in detail, and he will explain some of the nitty-gritties that he had to go through to accomplish this task. So I will let him start his presentation, and then you see how he has managed to do it. All
All
right,
right,
Omar, over to
so
you.
thank you. So I'll start with a quick demo of how everything looks. First of all, I have the odometry feedback here, and I will launch my launch file that has all the files together. So the robot is gonna find the wall, right? And it's gonna go as close as possible to it, and then it's gonna start going around next to the wall. And this is going to be done while subscribing to the laser scan. When it's closer to 20 centimeters, it goes left, and if it's more than 30 centimeters, it goes right. So it's always close to the wall.
All right.
And when it finds a wall, when it finds a wall in front of it, it turns 90 degrees. So that's how it keeps going around. In the meantime, I have the odometry here that is showing us the current total of the distance, and when it reaches 6, it should be able to stop because 6 meters is 1 lap around the circuit.
Okay. Okay.
All right, so that's it,
All right. All right. I see.
and the odometry just stopped, and this is the current total, which is 596.
All right.
Uh,
Okay.
so
So
now, yeah, go ahead, please.
I was gonna ask, is that all, or you wanted to get into some details?
Yeah, so on the video, I think that is all, and I can get into the presentation if you'd like.
Okay, let's go for it.
Okay, so this project is a ROS Basics project, and I used topics, services, and actions to be able to achieve this demonstration. The problem statement is to create an autonomous robot that moves along the wall. So I'm gonna detect the nearest wall. I'm gonna go next to it, and then I'm gonna turn in the direction of the I need to go to, and then I start hugging the wall along the lap, and I record odometry data while I am going around the lap until I reach 6 meters, which is exactly 1 lap. So the solution here is I'm gonna need to subscribe to the laser scan to detect the walls, and I need to use the ROS services to align with the nearest wall. And after that, I need to do the wall following behavior is gonna be subscribing to that laser scan every single time, and every single time I have the callback function that calls it and tells me exactly when where I am where the wall is and how close should I go. If it's more than, as I said, if it's more than 20 centimeters, uh, I am on the right direction, so I keep going. But if it's more than 30 centimeters, I need to go back next to the wall. And if it's less than 20 centimeters, I need to go further from the wall. And then I also use the ROS odometry data that is going while using ROS actions, and that is going to help me keep track of that distance to know if I reach the 6 meters, which is the lap. To do that, I had three files here: the find wall file, and which is my server, my ROS server that's going to be able to rotate towards the nearest wall, and then the main follower. The main follower is going to be the one that actually has all the clients and the subscriber that goes around the wall, and then the odometry recorder, which is also an action server that is going to be that is going to keep up with the odometry while I call it from the wall follower file. For the code breakdown, I'm gonna go directly to my code editor here, so I can show you exactly how it looks.
Okay.
So here, this is my find wall. My find wall here, I call this is the server that actually finds the wall and goes next to it and then rotates so I can start the wall following behavior.
Okay.
Here I have the laser data. I call the laser data the subscriber. I call the publisher, and I also start the service. I also added a while loop here. I found a little issue with calling the laser data is the fact that when I call it, it takes a little bit of time to actually start getting that laser data, and sometimes it does not the code goes directly to the server, and it does not call the laser data because I have this if function here that says if I don't find the laser data, then tell the robot that I did not find the wall because I have no laser data. And that would be if, for example, the laser is not working or something like that. That would be a way to know it.
Okay.
And so I added this while loop, so I make sure that I have that laser data before I go through with handling how it moves around the wall.
Okay.
I also subscribed to the laser data here to get the ranges, and then to be able to find the wall, I put this function here, this if statement, which is going to tell me where the robot is. Is it rotated more than 360 or like more than 180 degrees or less, so I know which turn I need to do, right? So if it's less than 180 degrees toward the wall, I would turn right. And if it's more than 180 degrees, I would turn left. So it's always the shortest turn that I'm going to make.
Okay.
And 360 is the middle. So from 0 to 360 degrees, it's for the laser data is from 1 to 720 increments. So from 1 to 360 increments, it's equivalent of 0 to 120 and 180 degrees. Then when I move towards the wall, which is what this if statement does,
Mm-hmm.
I move towards it until I am 0.3 meters to it, and then I turn. And this while loop ensures that I am looking at the wall with a distance of at least 30 centimeters. And
Okay.
then I'm on this while loop, I make sure that the robot is turning towards the wall. And I believe that's what the service does. So in the beginning, I have a disoriented robot. The robot finds the wall, finds the nearest wall, and then it turns around it with the smallest turn, turns towards it with the smallest turn,
Mm-hmm.
gets to the wall with this while loop here. And when it gets closer to the wall, it turns to the direction where I need to start the the wall following behavior.
Okay. I see.
So I think that's it for the server. I'll move to the action server. So here in the action server, I also called, of course, the messages. the odometry record action, the feedback, and the results.
Okay.
I called the odometry because I'm gonna need to use it here. I also called the point 2032, so I know. So I calculate. I always calculate that distance. Here I start the server, and I have a list. I have a list that is gonna put all the waypoints of the robot that is gonna go through, and then the distance is gonna add all those waypoints together so I can have a total distance. And I subscribe to the odometry so I can get that odometry data and I start calculating it. Here, this is the my callback function. It's pretty much straightforward. I get my current position, right? And then I calculate it with my previous position. And then I add it to the total distance here. And I append it to my list. So the Odom list is gonna have it's going to be a list of positions of whenever I call the odometry, and the total distance is going to be the added distance along the way. And whenever I reach that 6 meters, the robot is going to stop. Here, this is the function that actually calculates the distance. So
Okay.
it's normal Euclidean distance, right? And here, this is the execute function that actually calls the odometry. And this is the preemption if I want to stop it, which is always needed when you make an action server. And I believe that's pretty much it on this side.
All
I'll
right.
move to the main follower. And the main follower here is going to be my main file
Mm-hmm.
where I call everything. First of all, uh, I publish to the twist. I create my publisher,
Mm-hmm.
and then I call all my services. The first service client I need to call is the find wall that we've talked about first,
Okay.
because I need to find the wall first,
Mm-hmm.
and then I call the odometry so I can start the odometry. Since whenever that service finishes, I know that I'm gonna need to start doing that wall following behavior,
Okay.
and then I call my laser subscriber. And I'll go through the laser subscriber right now. So I also created another function that's gonna be able to stop the robot when I finish uh, when I finish when my odometry reaches 6 meters.
Okay. Okay.
Here, this is the client to record the odometry. So it's pretty much straightforward client. I create the client, and then I wait for the server to be connected. I send the goal to it, and then I wait for it until it sends me a result.
All right. I see.
Uh, this is for, of course, the odometry, and then when the result is given to me, I'm gonna be stopping the robot. So the odometry is going to start when the service is finished, because it's called when the server is finished, because it's called literally after the server, as I showed you here.
Okay. Okay.
And it's going to start the odometry while it's going around the lap. And then when it finishes, of course, the 6 meters, which is part of the goal, is going to stop. It's going to stop the robot.
All right.
Here, the service client is also straightforward. It calls the server and it sends the request and it waits for it until it finishes, and then it sends the result back. In the in the laser callback function, here, this is where everything happens. This is where the wall following behavior happens. I have I get the scan from scan.ranges, so I put them on this self.laser.
Mm-hmm.
And then I get the front distance and the right distance, which is the two most important ones, since I need to know where the right wall is and where the front wall is at all times.
Okay.
So
Okay.
when the front distance is less than 50 centimeters, the robot is gonna turn left
Okay.
and for 90 degrees. And then if the right distance is bigger than 0.3, it's going to turn a little bit right. And if it's closer, which is less than 0.2, it's gonna turn left. So it's gonna always keep the robot between 20 centimeters and 30 centimeters. And uh, if it's in between 0.2 and 0.3, then the robot just continues straight, which is this else statement here.
All right, all right.
And then I publish my move when it finishes, and it goes and it continues looping back into this laser callback function. So at all times, I know exactly where the robot is. I know exactly where I should be going and what the laser is telling me. And I believe that's pretty much it. And here I just call the function, call the class
All right.
to start.
All right. So that's it. Is that right?
I can go over here. I can go over the CMake listen package XML if you would like.
No, I don't think that's very important. I quite like the details you've given us so far. And if you don't mind, I have a couple of questions I'd like to ask you. But so far so good. I'm impressed with the way you have done it and the clarity of your methods. Right. So just for some get some details. Can you please give me some information about how well your robot doesn't really encounter obstacles, right? Because you're just checking the distance between the wall and the wall on the right and the wall that is perpendicular to the direction in
Yes.
which it's moving, right?
Yes.
But in the event that you would have an obstacle, have you thought about any criteria that you can use to avoid or to differentiate between the wall and the obstacle?
Well, that was not included in the class, but I have there could be a solution on that. If I want to include that in this, I probably need to make sure that the robot knows what's the dimensions of the lab.
Ah,
So
okay. I see. I see.
I know if it's actually what I'm coming up to. Is it the next wall, or is it another obstacle that I need to move around,
Mm-hmm.
and
I
then
see.
I find the right wall.
Yeah, yeah. Oh, that's good. I like the fact that you took dimensions in consideration, right? Because when you think about it, the wall is almost like the biggest thing you've got, or it's the data that's going to give you almost the widest ranges data if you think about it, right? So an obstacle would be different from the wall in terms of how big it is or how much of the range the projected lasers it takes to detect in a certain way. So that's quite good. It was a little bit of a push, but I just wanted to see how you would think about it. But yeah, that's good. The other thing I wanted to speak about is you spoke about using an action server to keep track of odometry data, right? And then
Yeah.
before we get into why you had to use an action server, well, I want to know why did you choose 6 meters, right? Because the track is well, it's slightly less than 6 meters, but I just want to get your reasoning on that. Why did you use
Yes.
that as your
So it actually did stop before 6 meters because before I get that feedback, that 6 meters goes through the code way before, so I never get that part of the feedback. I get it as a result. So when it gets to 6 meters, it literally stops before I get that before the feedback function is called.
Oh, okay,
And
okay. See, I think you might have gotten me wrong. I think it's less than 6 meters. That's what I meant to ask. Um,
yes.
so you can go ahead and explain. Yeah, sorry.
So, and the second part of your question, you said, why do we use the action server instead of the normal server, right?
Yeah. Why? What's the difference? What made you opt for using an action server when you want to keep track of odometric data? Right. What's the
Yes.
reasoning behind
So,
that choice?
so here, I'm going to give an example with my server here.
Mm-hmm.
If I go to my clients here, when I call a normal server, what happens is, sorry, what happens is I need to wait for the server to finish my request. So I send a request to the server, and it tells me, okay, I'm gonna find the wall,
I see.
and then it starts looking for the wall and everything. But I cannot do anything in the meantime while it's doing my request.
Oh, okay.
However, if I use an action server, I'm gonna be able to do that, and that's why we opted here to use an action server for odometry, because we are also doing the wall following behavior with the laser callback function here. And so the odometry and the laser could work at the same time.
Okay, that's pretty good. Well done. That's good. The other thing I also wanted to ask is on how the method in which you track odometry data. You spoke about waypoints, right? Can you get into a little bit of detail why you chose to use waypoints? Are they just point markers, or what's going on there?
So I just used waypoints because it was easier for me to comprehend.
Okay.
Uh, Here, I just have an odometry list,
Mm-hmm.
and whenever I have a new whenever I have a new callback function, which is a new waypoint,
Okay.
I just append that to the odometry list. But what's more important here is going to be the total distance, because
Okay. So
uh, I,
are you saying that your as your action server is going, it's going to get to a waypoint and then record that it has reached a certain distance, right? So let's say if you have a waypoint at 1 meter after the beginning, would it record that is past the 1 meter mark? Is that what's going on?
well, essentially, it's gonna be calculating the distance along the time, along with when it's going. So when I call that callback function,
Mm-hmm.
uh, it's gonna go through this statement here, this if clause, and it's gonna calculate the distance from the last position that I have here.
All right. So
And
waypoints are like
the last position is gonna be the last index that I put on my odometry list.
okay. So the waypoints that you put on your odometry list, they're for you, right? Because your robot is calculating odometry distance every time. So um,
Exactly.
it is a continuous checker, but you are doing it for yourself by putting markers that you keep as milestones of
Yes.
some type.
Exactly. So
Okay.
keeping it as a log. So when I come back to it, I know exactly what is exactly the robot's trajectory and how it was able to go around the lab.
Okay. Okay. Have you ever used this odometry list for any debugging session or anything? I'm just curious.
Well, I've used in some of the tests I was using where I do autonomous navigation, and I would like to know how uh, what is the exact trajectory that the robot has made. So I have a log of that in a list, and it tells me exactly how the robot behaved.
Okay, I see. So it's very handy on debugging. Okay, that's quite smart. That's very very nice actually. Um, yeah, I think. Do I have any other questions? No, that's it. That's it from my end. I quite like your project, so well done on that. Can you just explain why you chose ROS One? Is it because the project was done in ROS One?
Well, actually, it's not that because I've done a lot of research with robots, and I've worked with robots all the time right
Yeah.
now, and I did, when I see all the applications around, I've seen that a lot of people use ROS,
Okay.
and I thought that the ROS one is the way to start,
Okay.
because I'm also working on ROS 2,
Okay. I see.
and I thought it was when I started working on ROS 2, I understood that it was a great choice to actually start with ROS 1 and understand how everything works, how the topics work, how the
Right.
nodes work together. So I am ready to go further and work with autonomous navigation and get to the next level of automation.
Okay. All right. That's good. Well done, Omar. Well done. Your project was good.
Thank you.
So let me just do a wrap up, and then we'll continue on this Zoom meeting.
All right.
All right. All right, so that was almost project, and if you would like to do any of the projects that we offer certification on, you're welcome. Take a look at our platform, and then you will be able to see where you can start. And again, we advise you keep pushing your ROS learning. So until next time, bye bye.